compound interest is the interest on a loan or deposit calculated based on both the initial principal and the accumulated interest from previous period. Formula compound interest A equal P bracket 1 plus R divided N bracket power NT, where P is principal amount, R annual nominal interest rate, and number of time is the interest compounded per year, T number of years. Annuity. Annuity concepts enable people to plan for the future in terms of investment or saving. Formula annuity. The future value of an annuity, FV equal P multiply bracket 1 plus R bracket power N negative 1 divided R bracket. The present value of an annuity, PV equal P multiply bracket 1 negative bracket 1 plus R bracket power negative N divided R bracket. Part A, question 1A. Eliza invests 25,000 ringgit in an investment stream for 15 years. The investment rate offered was 5.5% compounded every 4 months for the first 10 years and 7% compounded every 2 months for the rest of the period. Find the future value of the investment. First, we use the compound interest formula, which is S equal P bracket 1 plus I bracket raised to the power of N. For the first 10 years, the principal is 25,000 ringgit. The annual interest rate is 5.5%. Since it is compounded every 4 months, there are 3 compounded periods in a year. The number of periods over 10 years is 3 times 10, which is 30. So, we calculate 25,000 bracket 1 plus 0.055 divided 3 bracket raised to the power of 30. This equals 43,160.033 ringgit. Now, for the next 5 years, the new principal is 43,160.033. The annual interest rate is 7%, compounded every 2 months means 6 periods per year. Over 5 years, that is 6 times 5, which is 30 periods. We calculate 43,116.033 bracket 1 plus 0.07 divided 6 bracket raised to the power of 30. This equals 61,060.73 ringgit. Therefore, the future value of Eliza investment after 15 years is 61,060.73 ringgit. B. In 10 years' time, Arif wants to have enough money to pay 10% down payment on a bungalow that costs 450,000 ringgit. He invests in a savings account that pays an interest of 6.53% compounded semi-annually. B1. Find the amount of the down payment that he needs to pay for the property. This part of the question simply asks for the down payment amount itself, which is 10% of the house price. So, down payment equals 10% of 450,000 ringgit. We get 45,000 ringgit. B2. How much should he invest today to have enough money for the down payment? We use the present value formula, which is S equal P bracket 1 plus I bracket raised to the power of N. The future value needed is 45,000 ringgit. The annual interest rate is 6.53%. Since it is compounded semi-annually, there are 2 periods per year. Over 10 years, the total number of periods is 2 times 10, which is 20. So, we calculate 45,000 equal P bracket 1 plus 0.0653 divided 2 bracket raised to the power of 20. Next, 45,000 divided bracket 1 plus 0.0653 divided 2 bracket raised to the power of 20 equals P. This equals 23,667.344 ringgit.
In this question, 7,000 ringgit was invested for a total period of 5 years. For the first 3 years, the bank offered an interest rate of 5% compounded monthly. For the remaining 2 years, the rate changed to the R% compounded quarterly. At the end of the 5 years, the accumulated value became 9,560 ringgit. We need to find the value of R. First, we calculate the value after the first 3 years using the compound interest formula, S equal P bracket 1 plus I close bracket to the power of N. We substitute P equals 7,000, the monthly interest rate 0.05 over 12, and N equals 36 months. This gives us an accumulated value of 8,130 ringgit and 31 cents. Next, this amount continues to grow for another 2 years under a new interest rate R, compounded quarterly. So, we form the equation 9,560 equal 8,130.31 bracket 1 plus R over 4 close bracket to the power of 8. After simplifying and solving the equation, the value of R obtained is approximately 8.182%. In this question, Faris took a loan of 65,000 ringgit from a bank that charged 4.25% interest compounded monthly. After several years, the total amount he needs to pay back becomes 80,360 ringgit. We need to determine the value of T, and the amount of interest charged. We use the formula for compound interest. S equals P bracket 1 plus I close bracket to the power of N. We substitute the principal amount, the monthly interest rate, and the final amount. After rearrange the formula and apply log, we solve for N, which represent the number of months. Convert months to years, the value of T is 5 years. To find the interest charge, we subtract the principal from the total amount. 80,360 minus 65,000 gives an interest of 15,360 ringgit. For the part B, question 1A, Zachary invests 800 ringgit every 6 months into an investment sim. The investment lasts for 12 years and 6 months, and it earns an interest rate of 5.4% compounded semi-annually. We are required to find the future value at the end of the investment period. Since this is a periodic investment, we use the future value of an annuity formula. S equals R bracket 1 plus I to the power of N minus 1 close bracket divided by I. We substitute R equals 800, the semi-annual interest rate 0.054 divided by 2, and the number of compounding periods, which is 25. After performing the calculation, the total future value of Zachary investment becomes 280,445 ringgit and 33 cents.
For this question, Alia took out a loan with an interest rate of 4.4% per annum, and the interest is compounded monthly. She makes monthly payments of 237 ringgit and 42 cents. After making the 50 payment, she wants to settle the entire loan balance. To find the outstanding loan balance, we use the formula for the annuity value, which is A equals R time bracket 1 minus 1 plus I power negative N close bracket divided by I. We replace the value of R with 237 ringgit and 42 cents, and the monthly interest rate is 0.044 per 12. Since Alia has paid 50 months, the remaining loan period is 22 months. So we use N equals 22. After calculating, the remaining loan balance that Alia still has to pay is 5,009 ringgit and 31 cents. In the next question, Neledia takes out a loan of 240,000 ringgit, and the monthly payment to be paid is 3,146 ringgit and 88 cents. The interest rate is 4.5% per year, compounded monthly. We use the annuity formula, which is A equals R time bracket 1 minus 1 plus I power negative N close bracket divided by I. We enter the loan amount of 240,000 as A, the monthly payment of 3,146 ringgit and 88 cents as R, and the monthly interest rate of 0.045 per 12 SI. Then we rearrange the formula to find N, which is the number of payments. After doing the logarithmic calculation, we get the value of N equal to 90. This means that Neledia needs to make 90 monthly payments. In the second part of this question, Neledia failed to make the first 10 payments, so we need to calculate the total arrears accumulated after 10 months. We use the formula for the future value of annuity, which is S equals R bracket 1 plus I power N minus 1 close bracket divided by I. We enter the monthly payment value 3,146 ringgit and 88 cents, the monthly interest rate, and N equals 11 because these arrears will be compounded until the 11th month before being paid. After calculating, the total arrears that Neledia needs to pay in the 11th month to settle all arrears is 35,272 ringgit and 80 cents.